Well, hello everyone. It's time to start. I'd like to welcome you all and to thank you for being here in this webinar. My name is Aldo Sponton. I'm a tech manager in the Artificial Intelligence Studio here at Globant. And today I'm here to present a couple of experts in the area that they are going to talk about face recognition and voice recognition. We have Pasquinel Urbani. He's a software designer and a data scientist here at Globant. And we have a special guest from AWS, from Amazon. His name is Jesus Federico. He's a solution architect in AWS from Chile. And he will be giving us some beautiful material, beautiful presentation about the Amazon solutions. Just a couple of comments about this activity. We have a Q&A section. You are going to see in the screen, down in the screen, you're going to see a Q&A. You can post your question whenever you want. We will be seeing it, and we will answer those questions after the presentations. Please don't use the chat for the Q&A. Just type the question in the Q&A section. And another comment, we will be recording this webinar for you to have it, to see it whenever you want. This webinar will be public in YouTube just after it finishes, so you can see it. Anyway, you will receive an email with the correct link and stuff, so you can see this material. And with those comments, I'd like to present the first speaker, Pasquinel Urbani. He will be sharing his screen. He will be showing his presentation, and he will speak about speech recognition in particular. So, Pasquinel, your turn.
Thanks, Aldo. 1 minute, please. Okay, now I'm going to share my screen here. Okay, so is the display okay? Yeah? Okay, nice.
Yes, Pasquinel, go ahead.
So, okay, frontiers of speech recognition. The aim of this talk is to basically give you an overview of how speech recognition has become what it is today, and now what tools can you use to incorporate to your business to make the most use of artificial intelligence today. So today's roadmap is, first I'm going to talk about the studio at Globant, what about AI and machine learning, history of speech recognition, big steps, how it works, speech recognition now, high-level APIs for speech recognition, and high-level APIs for natural language processing that we are going to complement after, and some success cases. I'm going to need to be very quick in this because we don't have that much time. Okay, so the AI Studio was born from the success of the Big Data Studio and years of listening our customers. We provide custom solutions based on machine learning, pattern recognition, and natural language processing, and data analysis in general. So this guy is named Andrew Ng. He's a teacher at Stanford University, and he's one of the main reference points of development of machine learning and artificial intelligence. Andrew says that artificial intelligence is the new electricity. And why does he mention this? Because he compares the impact of artificial intelligence in having the impact that electricity had in the 19th century and the beginning of the 20th century. So back in those days, electricity was the key factor in development of a huge list of industries, becoming the backbone of modern industry society. Nowadays, artificial intelligence is having similar impact on a bunch of industrial verticals. So the impact of this technology is expected to be similar, and it's being similar to the electricity in that time. So here you can see what is expected to the impact of artificial intelligence and different branches of it in the whole industry and different industries. So quite a lot. So, quick review, what is machine learning? While there is a more current definition, I like to use this one made by Arthur Samuel in 1959, which says that machine learning is the subfield of computer science that gives computer the ability to learn without being explicitly programmed. So we have been writing code to tell computer what to do. So now what can we do? We can give the computer data, and the computer can learn about that and make its own decisions after. So that is the big step of machine learning. So a little bit of history of speech recognition. Speech recognition has become very trustworthy in the last few years, but now not always was like that. There is something with being capable of give the machine the human capabilities that amaze us, and that's awesome. So speech recognition is a subfield of computational linguistics. The main objective of speech recognition is to build systems capable of translating spoken language into text, and that's it basically. So the first try wasn't that strong, and this was one of the better ones at that time, but not successful enough. The group DARPA at IBM tried to do it, and yeah, it was better, but not enough. The language was very constrained, and there was not that much to explore here. So the last try at the beginning of the 90s, or at the last 80s, was using actually recurrent neural networks to speech recognition, but they weren't much successful. So the 90s was like a time where nothing happened in terms of speech recognition and deep learning in general. People have already took chances to do it, and not that much was achieved at that time. So we actually want to know why, and why now is a big thing. So what we have now, we have deeper networks, we have context-dependent states, large amount of data, and computer power through CPUs. So there is not that much things that changed from the late 80s, but now we have everything better done, with more context, with more data, and with more CPUs. So let's go in detail. One of the biggest problems with plain record, this is a recurrent neural network. It's a neural network that can read things that are sequential. That's basically the idea. But the problem with recurrent neural networks is that they cannot remember context because a thing called vanishing gradients. So one of the big steps in making the recurrent neural network works was adding some feature called LSTM, long short-term memory, which is like an inside system inside each cell, capable of discerning where when something is worthy to remember and when it's not, and to give weights to that thing. So that was one of the big steps. So second, the spectrogram, which is a representation of sounds in the time frequency space. The intensity of the color represents the wave amplitudes. This is complemented with the association with words in acoustic models. So what we have here, we have in the x axis the time, and the y axis the frequency, and times the scale of the frequency can vary, and you can choose many of them. And the color and the intensity of the color is the amplitude. So basically, you can have a graphical representation of sound. This is the word yes, for example, and that word can be described in many ways and many scales. So is a valuable input to our models. So an acoustic model is the field that contains statistical representation of the distinct sounds that make up a word. So all these that you can see here are different representations of the same word. Okay, so the English language has about 40 distinct sounds that are useful for speech recognition. Thus, we have 40 different phonemes and different descriptions of them. Okay, so spectrograms can be represented at different scales, and all these representations combined are capable of providing feature-rich representation of words. So that's what I meant when I was talking about that now we can look context, and we can look for better representations, better input data. Okay, so that's different, and that is important. Something that neural networks are capable of, it's making their own feature engineering. And I'm going to explain this using the convolutional neural networks because it's easier to reach the intuition for that. So deep neural networks are neural networks with many layers. That's it, basically. You use convolutional neural networks for image recognition and recurrent neural networks for speech recognition and things related to sequential things. So if you build a deep neural network, for example, of this image, you can see that the first layers can understand the low-level representations. So diagonal lines you can see here. I don't know if you see my mouse. I'm not sure. Can you see my mouse? Yeah? Okay.
Yes, we can.
So you see low-level representation. Then in the upcoming layers, you can see high-level representations of, for example, you can see here wheels or chassis or different things. And the latest layers represent some high-level features like the car itself. Okay, so for speech recognition, the intuition is similar. I prefer not to explain because it's going to create more confusion. But this is basically the process that deep neural networks use to describe and to classify something. Okay, so that's it. We have low-level representation. We have the input data. The input data as a spectrograms, which we use a language model. We stack many layers of this recurrent neural network, and we predict which letter and lately which word is the person or whatever emitter is saying. And that's it. Speech recognition today. Someone say that it's easy for people, incredibly hard for machines. Yeah, many years of failed tries, but voice recognition has had an important quality leap in the last 2 years because now actually does work, not like years ago. So this speech recognition technology has advanced rapidly, particularly the past 10 and 15 years, and it's becoming commonplace in the bedroom, kitchen, and the rest of your house. It's light years beyond its first iterations in the 90s, when one of the earliest commercial products was the Dragon Dictate. Nobody remembers that, but it actually happened, but it wasn't that good. As it is today. a typing software released in the 90s that was the error prone and cost $9,000, so a lot. So voice recognition cannot only be utilized by domestic purpose. There is a huge industry dedicated to provide voice recognition services as a REST API that can be easily plugged into any service software that we are going to see later. So we are used to these things right now, like Alexa or Cortana, but it's not something that common in the past years. So, okay, so how much time? Okay, I'm good. So what can you do now? And this is the important part. Today, okay, so you can train your own neural networks and do whatever you want, but it's very computational and data intensive. So we recommend you to go to the big companies which are providing services for these kind of things, which are the known ones, as IBM Watson, Google Cloud, Microsoft Azure, and Amazon Web Services. Some of the services are, of course, automatic speech recognition in over 150 languages. So that's quite a lot. Capable of performing real-time transcriptions and with a human-like accuracy. We are talking about human-like accuracy. So those systems are very trustable. Other like site services that you can use, phrase hints, which is a speech recognition can be customized to a specific context by providing a set of words and phrases that are likely to be spoken. This is especially useful for adding custom words and names to the vocabulary and in voice control use cases, because maybe your business have some special keywords that you want the system to remember, and you can customize that. No problem. If happens that in your company there is a recurring word that is very context specific, you can use this. And then you can use tone analyzer, and this is a very useful tool. Tone analyzer can understand emotions and communication style in text. So yeah, you can track behavior, you can track emotions, you can track satisfaction in your customers and in whatever pipeline you want to in your company. Conduct social listening, analyze emotion and tones in what people write online, like tweets, reviews, predict whether they are happy, sad, confident, and more. This is especially useful for products that are really that are discussed in the web. Gaming is one of them. It's very useful for this kind of stuff. You can integrate this with chatbots to enable your chatbot to detect customer tones, so you can build dialogue strategies to adjust the conversation accordingly. And okay, so this is one of the things that you can do, but there is another branch, which is natural language processing, which is it's very similar. It's not exactly the same. This is a more like broad term. These companies also have this kind of things that you can track sentiment analysis. For example, you can do the speech to text, then analyze the text, and for example, know if the person have said something negative or positive or neutral. Also, you can track some entities. You can summarize the text to know if a company was named, or a place, or something that you want to customize to identify. Key phrases for understanding better what is going on, and more advanced tools like syntaxes, and which I'm not going to go deep in here, and categorization of text, which is self-explanatory. Okay, so many tools. It is up for your imagination. You can do whatever you want. You just need to figure out what you want to do. Some success cases. Home Assistant is one of the fastest home automation platforms. Yeah, this is open source. And this is awesome. This is an app that you can download, and you can like totally automate your home functionalities. And it's open source. There is a lot of hype around this project, and I invite you to check this. So quickly, other applications of deep learning that you will be able to find also in this kind of services. Object recognition, recognize object in an image, and this is pretty fast right now. You don't need that much computational power to perform this type of tasks. Face recognition, image captioning. So you can have an image, and the computer can tell you what is in the image. So from image to text. Speech generation, to create histories based on some customized training that you can use. This is an example of speech generation. And other things like style transfer, which computer can take the shape of a image and output the shape of an image with some specific style. So it's very good if you want to create customized visual things, visual web page. Well, music generation, this is not especially useful for business right now, unless you can create something useful. And there is a lot to learn. I have presented you some functionalities. I think you can continue exploring this. We can help you whatever you need to build your tools. We can integrate you with your current business. And thank you very much. That's it.
Thank you, Pasquinel. We have one question that we are gonna answer at the end of Jesus' presentation. Remember, guys, you can ask your questions in the Q&A section down in the Zoom window. And now I will let Jesus to share his screen and start his presentation. Thank you, Pasqui.
Thank you, Aldo. Let me put my screen in full screen mode. Can you see my screen?
Yes, we can. Go ahead. Jesus.
Right. Thank you very much. My name is Jesus Federico. I'm a solution architect working for AWS in Chile, in Latam. So basically the idea today is provide you an overview of what Amazon Web Services has in terms of artificial intelligence, what tools and what service can you use for building your applications using this technology. But I would like to start saying something about definitions. When we talk about artificial intelligence, is basically is intelligence demonstrated by machines, in contrast to the natural intelligence that is displayed by humans or other animals. Basically, we would like to teach or learn, make the machine learn, and in the way that they can interact with human in a natural manner. It's not about adapting the humans to interact with machine, is the opposite side. So as Pasquinel explained, machine learning is just a subset of artificial intelligence, and it's a field of the computer science that basically use statistical techniques to give the computer the ability to learn. So in Amazon, we have like more than 20 years working with artificial intelligence, and we develop many machine learning algorithms to drive our internal tools from the retail side, the Amazon.com recommendation engine, to the new existing products as Amazon Alexa, the devices Echo Dot, from the fulfillment centers using robots to optimize the path within the fulfillment center and just to provide an overview if the racks are filled or not, to our initiative like with Primer using drones to deliver packages. So behind the scene, we have a lot of experience and a lot of, we are investing a lot in artificial intelligence since 20 years ago. All right, so we built a new store that is Amazon Go. I don't know if you know, guys, but basically it's a store that where you can go pick up anything you want, and using computer vision and deep learning algorithms, there is no cashier. You don't need to pay. It's automatically charged to your virtual car, and you can just go without going to a cash pay. From the fulfillment center, as I explained, we have robotics, and we have used computer vision to identify empty spaces in the racks, so we can optimize the completeness of this. And from another point of view, we see that this kind of technology can be used for many things, from healthcare industry to agriculture optimization to utility grid efficiency, and there is no limit for using this kind of technology. In AWS, we define like 3 layers where we can start using artificial intelligence. Basically, we can start doing by using frameworks, a specialized framework for artificial intelligence, as TensorFlow, CAF, MXNet, and so on. But you need to be a machine learning professional. You need to know that. So basically, you can start by the base layer where you use tools, infrastructure, and you use frameworks. We build another layer that is a platform. Basically, we facilitate the innovation for any developer using machine learning. You don't need to be an expert in any framework. You just need to know coding, and then you can start building your custom models. And then we have a third layer that is an application service layer that you can, if you are a developer and you don't have any experience with artificial intelligence, nor building custom model, nor deep learning, you can start using those services that have a model that is already built to start using like computer vision, image recognition, video recognition, text to speech, speech to text, comprehend, sentimental analysis of a text, etc. Our idea behind this is our mission is just to put all the tools for machine learnings for any developer. You don't need to be a data science to start using this. So we would like to empower you to have all the tools that you need to start using machine learning. So just talking about the stack, I'm going to focus on some service, basically on vision and Sonom speech and platform. For vision, we have a service that is called Amazon Recognition, but basically it's a service that is built in model and you can use for recognize image and videos. And basically you can do like facial detection. You can use like demographic data, if it's a male or woman, is it happy, general attributes like where are the eyes, if are open or not, is if he's using is he smiling, have bare mustache, etc. Another case of use for recognition is basically you have a picture and you can detect like Pascual explain objects, do some scene detection. You will have labels. In this particular case, we can see in a skateboard, sport, people, parking, human, but they're using labels that are already trained in the model. So another case is just for like comparing faces or detecting text in pictures. There are many cases of use that we can use computer vision for end customer or for your business. All right. So I would like to share some of what have been happening with this service. 95 of our roadmap is driven by the customer. So the customer starts saying, okay, I have I can recognize image, but what about video? So last year we announced recognition video. So we can do the same stuff that we did in images, but in videos. And we can use real-time streaming to do like analysis in the video. You can detect 1,000 of objects with the timestamp that happened. For example, suppose that you have a baby first walk, and you can generate label like baby crawling, failing, hugging, with a timestamp and the confidence score that happened during that walk. So some of the customers that are using recognition, just a couple of logos, C-SPAN or on-prem influence, are using the recognition to, for example, to categorize a lot of people and just to put the name of important person if it's in a picture or not. I have several customers using this, for example, for news. When someone writes a news and upload a picture, you can detect if important person is in the picture and label that picture with the name of the person. So that's in terms of computer vision. When we start talking about the text, we have several ways. We have text to speech, which we have a service that is called Amazon Poly. Basically, use a deep learning algorithm to produce text to speech. But behind the scenes, what it's happened is like you need to use deep learning and intelligence model to say some words. For example, in this example, we have the temperature in SPGs 33 Celsius degrees Celsius. If we don't use deep learning algorithm, we can say that the temperature in SGP is 33C. But we need to understand that SGP is Singapore and the C represents Celsius degrees. So that's why we are using, we use artificial intelligence behind this service. Some of the customer, one of the most interesting is Duolingo, which is a cool company that many people use to learn another language. And they use Poly to produce the voice of the text where they're learning. Another topic about the text is about Transcribe. We have a service that is called Transcribe. Basically, it's the opposite way. You have voice, and then you will produce text. And this is a really cool service because it enables you to given a voice, put that in text, and then you can do many stuff like sentimental analysis. We can combine this service, for example, with a call center software or call center service. We have a call center service that is called Connect, and you can transcribe all the speech that you are talking within the call, and then you can do and analyze that text offline. So you can detect multiple speakers, you can have the timestamp, you can save that information in S3, which is the object storage. And you can even use a custom vocabulary. If this is available in many languages, even English, Spanish is available, but sometimes, as Pasquinel explained, you have like local words, or sometimes you have like custom pronunciation about some words, and you can implement that to tell Transcribe to recognize that in a different way. Then we have Comprehend. That is a service that enables you to do like natural language processing, NLP, And basically, it does the same thing that Pascal explained. You have a text, and then you can identify entities, you can identify places, the language, if the sentiment is positive, neutral, or negative. And what it's really cool, it's like these kind of service are, you can call this service directly by API. You don't need to be an expert of machine learning. You can start using this by calling an API, passing a text, and then you can start working with that. Then we have another service that is Translate. Is self-explained. It uses real-time translation. It's also powered by the deep learning algorithm. Behind the scene, it's the same. Sometimes you have a word, we cannot use like word by word translation. We need to have know the context, because sometimes it depends on the language that we are talking. We need to reorder some words to make sense in the target language that we're going to use. In the last service that we have in terms of text, that is artificial intelligence service and user service, is Lex. Lex basically is the heart of Alexa. It's what it's built to do the natural processing language and the natural language understanding, the NLU. You can build your own service using Lex, and it's what it powers many chatbots like this one, that you would like to book an hotel, and you can use text and you can use voice. Behind what's happening is just not to understand what the customer wants, it's just to understand the intent of the customer. It's not the literal phrase, it's just to understand the context, and you can have like a stateful conversation that you need to, for this instance, you will say that I would like to book an hotel. And then the chatbot starts to interact with you like, sure, what city? New York City. And what time do you would like? Okay, tomorrow. But you can start saying, I would like to book an hotel in the New York City for tomorrow with just one intent. So it needs to be intelligent enough to achieve or understand what the customer wants and traduce that in an intent. Some customers that are using Lex technology, I would say like NASA, Twilio is some Capital One is using. You can start building your, for example, your skill in Alexa, and behind the scene is going to use the Lex service. So we talk about a little bit about application service. Just to recap, we talk about recognition, we talk about text analysis, that is comprehend, poly, transcribe, and we talk about Lex, which is the natural language processing and natural language understanding. Then this is for the developer that they don't know really much the artificial intelligence, but they want to start using this kind of stuff. Then we have another layer that we call platform. This is a layer that in a typical way, when we start training our data for building a custom model, we start doing like this. We need to collect all the data, all right? We need to clean the data, choose which algorithm and which framework we are going to use basically on the objective that we would like to accomplish. Then we need to set up all the infrastructure to train. Then once that is trained and meets the objective, we need to deploy and then start doing some inference that are basically predictions. There is a joke in the data science team that says like 80% of the time is just about cleaning the data. And the rest of the 20% is just about complaining, cleaning the data. So that's a really joke. That's why we built a service that is called Amazon SageMaker. Amazon SageMaker is a full managed platform that enables a developer and data science to quickly and easily deploy and train and deploy machine learning model at any scale. It basically group this flow that we just saw in a couple of slides. And you can divide this in 3 steps: building, training, and then deploying. When we talk about building, we need to have data, and we provide a Jupyter node that you need to code in Python using Jupyter, and you need to choose which algorithm you can. It's better for your propose, and you can use any of the framework: MXNet, TensorFlow, CNTK, Torque, PTorque, CAF2, etc. And you can choose which algorithm would you like to use. Then we have to train the data, and to train the data is just one click. What happened behind the scene is when you train the data, we build all the infrastructure behind to process and to start building all the model. And you can start tuning your model, just setting up an hyperparameter optimization that are parameters that change the behavior of your framework or of your algorithm. And once you have your training data, and you need to deploy that in production. So we provide you a 3rd step using the same interface to easily deploy and create the infrastructure behind the scene to deploy and start doing inference. And if you need to scale up that and scale out that infrastructure, basically Amazon SageMaker enables you, and it makes you easier to scale that platform. Right. So some of the customers that are using SageMaker, Intuit, Tinder, Realtor, there is a cool demo that is a StatCast that is the statistics of the baseball league, Hotel Zendesk, the Dow Jones, etc. And in the same way, we have another product. This is a physical product and a service that is called AWS DeepLens. When you have a model that you can use for inference or predict any stuff, you can run this model. That you have to choose where you want to run this model. Suppose that you're running this model on the cloud. So if you're running a model on the cloud, you need to stream your video or all your data continuously to the cloud to do inference. So we develop a hardware that enables you to run, create your custom model, put your custom model in the DeepLens, and run this offline. You don't need to be connected to the internet to run this. And it's integrated with SageMaker, which enables you to create your custom model to identify custom objects, and then put that directly in this hardware. And it's just a hardware for developer, just for testing your model. And there is a lot of examples. You can check out that in the Amazon Web Service page. There are a lot of examples, for example, to detect if it's an animal, it's a cat or dog, or if it's a person, or what objects are seen. And you don't need to be connected to internet to do that inference. It's run directly in that hardware. And the last thing is just the lowest part of the Amazon Web Service infrastructure that we have. If you are a specialist, an AI specialist, and data science, you would say, okay, I am a specialist in TensorFlow. I would like to use directly TensorFlow or MXNet directly. Okay, you can start using TensorFlow or any framework that you would like to use using some pre-built image that we built. There are deep learning AMI, Amazon Machine Image, that have the framework already configured. So you can start using that the framework that you want, and then use the infrastructure and to train the data. We have instances that have GPU enabled using NVIDIA Tesla V100 that enable you to train in really fast and using GPU. Then you can use, for example, once you have the your model trained, you can use the inference by using a CPU model instant type. And once you have the model built and everything built, you can say, okay, I would like to deploy this to this model to, I don't know, a device. And you can use IoT device. And you can use leverage using another service that is Greengrass to put that information at that model using IoT. Or you can run that model directly in a mobile or whatever you want. Some of the frameworks that we support, as I explained, we have this AMI already built. You can start using that if you are an expert using these frameworks. You can start using MXNet, TensorFlow, CAF, Tiano, Keras, Torque, etc. And you can start also using some APIs that are directly provided by the hardware vendor. There are for Intel, NVIDIA, CUDA, Python 2, 3, Anaconda, and it's all powered by the EC2 instance that are the compute for Amazon Web Service, Elastic Compute Cloud. So some of the customers using directly this technology as Netflix, NVIDIA, Expedia, Pinterest, Edmund, TwoCents, even Intel, Zendesk, and so that's what I have. Thank you very much. If you have any question, this is my email. So Aldo, is all yours.
Thank you. Sorry, thank you, Federico. Very nice material. I will wait until you stop sharing your screen so I can share mine.
I'm trying to stop sharing my screen.
No worries, I can kick you.
Okay.
Thank you. We are gonna ask at least a couple of questions. Thank you all for being in this webinar. We have a question here from one of the attendees that says if the speech recognition system can work for regional accents. So maybe we can speak about that, Pasky. I'm gonna give my opinion. They actually can work on that. Some of the problem, in fact, some of the problem with Spanish, we are with Pasquinel, we are Spanish speakers, so we kind of have to deal with that problem sometime in our developments, and sometimes we have problems with different accents, but that's something that you can fine tune in the models. I don't know, Pasky, if you want to add some comments about that.
Yeah. I have worked with one of these frameworks. I'm not going to mention which one, and seems pretty robust in the sense that we worked with people from all over Latin America, and despite we had some problems, we managed to retrain the models to learn new terms and new way of pronouncing words that can vary within Latin America. And we were very successful on it. Yeah.
Thanks, Pasky. I'm gonna skip one question. I'm gonna talk about some barking recognition. That is a nice question. There's a girl here asking us if we think it's possible to develop barking recognition, and I think it's you're a pet lover. I think. I think we actually can develop a system that for recognized barking. The problem is that the acoustic models that are used in the speech recognition algorithms, maybe they are not the proper, they are not computing the proper features in order to recognize barking. You know, when we use acoustic model for voice, they are usually aligned with the important features in voice. For example, the kind of filters you compute when you calculate the spectrogram or stuff like that, they are specific for voice. You know, the range of frequency or stuff like that. Maybe with the correct filters or analyzing the audio in a best way, we can actually develop barking recognition. But it's a funny and nice project to work. And I don't know, Pasky, if you want to add anything. You are on mute, Pasky, sorry.
No, I think that you said enough on this. Yeah.
Okay, I have a question here for Jesus. One of the questions for Jesus is it's not here in the Q&A, sorry, but can I use the same models of Amazon recognition in the deep lens with this camera you presented?
Well, basically, you cannot use that. Amazon recognition have a pre-built model. And for the deep lens, you need to build your own custom model. You can use some examples that are already in the website. So you cannot use the recognition model and put that recognition model directly in the deep lens. You can create even your custom model and put, I don't know, to identify custom object and put that directly in the deep lens.
Thank you, Jesus. I will pick just another question. We have a lot of open questions in the Q&A section. We are going to try to answer maybe later in the communication we are going to give after this webinar, because we don't have time to answer all. But I'm going to pick the last one. Adore here is asking if we can baseline the sentiment or tone analysis. She's given an example like what happens if a person is, for example, contacting the police. There will be a baseline in the sentiment analysis after that we have to compute. So my opinion in that is it depends on the data you use to train. You know, if all the data you use to train is coming from those situations, in this case, from people that is contacting the police, of course, I think you will be able to extract different sentiments in that context. But if you have that data maybe mixed with other data, probably every data coming from people contacting the police will be in just one class, and you will not be able to detect like properties inside that class. So that would be my opinion in that problem. And it is an interesting natural language processing problem. Pasky, do you have any new word on that?
Yeah, I think first you need to think in first when you face a problem regarding recognition of tones, of sentiments, you need to ask yourself if there is first human possible. Then you need to generate the intuition, you need to generate the tools, the specific tools to go there. And after that, you can go to the next step. But I think if the data is good enough and you have enough variation in your data, in the tones, in the sentiments of each call, you can do it. But you need very quality data to perform that task.
Thank you, Pasky. And we just have 2 minutes left, so we will be sure that all the rest of the questions will be answered in the communication email after the webinar. I just want to thank you all for being part of this webinar. We had a lot of people. We have very interesting presentations. We want to repeat this kind of activities with other deep learning and machine learning techniques. They are pretty used right now, and they are pretty powerful. Last but not least, there will be a recording of this presentation in YouTube. It will be available just as soon as this webinar finishes. And that's all for me. Thank you, Pasquinel. Thank you, Jesus. And thank you all for being here. We are finishing this webinar today. Have a great day.
Thank you, everyone. Bye.
Bye-bye.